But this is a very important and very topical presentation now being made by Nina Wyers from the Floorbrite group, who are based just over there, and she will be looking at cleaning for climate change. So with no further ado, I'll introduce you to Nina.
Thanks, Neil. Right, welcome and thank you for joining me today. My name is Nina Wyers and I'm one of the family owners and the marketing and brand director of the Floorbrite group. If you've not heard of us before, we began 50 years ago and today we are one of the leading commercial cleaning and soft FM providers in the UK. So today I'm here to talk to you about climate change and to just have a conversation around what that means for the world and human life on this planet. Then I want to talk to you about how the cleaning industry contributes to this issue and some of the areas that we really need to look at and address as an industry. Before I start, I need to tell you I'm not a scientist, I'm not a manufacturer, and I'm not an expert in climate change either. I'm just a normal person like you. I've grown up in our industry though and worked in it for the past 23 years. What I am, however, is passionate. I care a great deal about what I do, what we do, and how we do it. That's why my interest has grown so much on this subject over the last few years, and I've written a number of articles on the importance of waste and environmental management, recycling and environmental innovations in our industry. However, more recently I wanted to delve deeper and take a more in-depth look at the consequences of climate change and if the green innovations available to our industry are as green as they say they are. Around plastics and cleaning chemicals. This is why I have conducted months of research to pick through the confusion of it all and try to bring some clarity to what you might want to look at when you're seeking to achieve your own environmental goals. So in the first instance, I'm going to give you the facts about climate change, and it's not pretty. Apparently, we only have 9 years left to make a difference. Climate breakdown will occur within the next 9 years unless we see that difference. It's not a lot, is it? But thousands of years have led to this point, and we only have a few left to reverse the effects of climate change. So what is global warming and climate change? The global warming definition is one that many organisations such as National Geographic, the Met Office and other environmental groups agree on. It is the greatest environmental challenge facing the planet today. Global warming is caused by the increase in concentration of greenhouse gases in the atmosphere related to human activities. Global warming is the cause for climate change. The more greenhouse gases there are in the atmosphere, the more heat is retained, just like a blanket. And the largest contributor to an increase in greenhouse gases is human activity. So it's up to us collectively to reduce that, because climate change is changing so rapidly that some living things cannot adapt. According to the National Oceanic and Atmospheric Administration, NOAA, the January 2020 global surface temperature was 0.8 degrees Celsius above pre-industrial levels. That's pre-1850. Warming of more than 2 degrees Celsius could have irrevocable consequences on the environment. But global warming of more than 1.5 degrees would also have unprecedented climatic consequences, such as bigger and more intense storms and rain, followed by more prolonged and intense droughts, which will become more frequent and intense and have irreversible repercussions on the environment. I'm sure that you will agree they're already happening on a more frequent basis. Nevertheless, climate change varies from place to place. For example, the polar zones are warming twice as fast as the rest of the world. Continuing the current trajectory of global warming, the Arctic ice sheets could completely disappear in a few decades. And it's happening at a faster pace than scientists expected. In the UK, research carried out by the Met Office shows climate change is happening here too. The 10 warmest years on record have all happened since 2002. 7 of the 10 wettest years on record have all happened since 1998. And it predicts that by 2070, UK winters will be between 1 and 4.5 degrees Celsius warmer and up to 30% wetter. And summers will be between 1 and 6 degrees Celsius warmer and up to 60% drier. The main environmental impacts are the following. Melting of the polar ice caps and rising sea levels. Did you know that 95% of the Arctic ice is gone? It is warming of the thickest ice is gone. It is warming faster than anywhere else on the planet, and ice is declining by 10% every 10 years, which means the Arctic will have ice-free summers by 2040. The Greenland ice sheet is melting 4 times quicker than in 2003 and currently contributes over 20% to the rising sea levels. If this sheet melts entirely, the seas will rise over 20 feet. Located in Montana, Glacier National Park had over 150 glaciers in 1910. They now have less than 30 glaciers left, and predictions show all of them could disappear in the next 30 years. Scientists predict over a third of all remaining glaciers in the world will melt before 2100. 2 weeks ago, I watched a report on the news that said an ice shelf the size of Rome is currently breaking away from Antarctica. What does this mean for you? Sea levels have increased by 8 inches over the past 100 years, but scientists estimate a further 1 to 8 feet rise by 2100. The UK could look like this in our lifetime. All the red areas will be underwater. And this is a closer look at our region. Donald Trump says, hey, it's not a bad thing. It just means more beachfront property. But I personally fail to see the positive. There will be changes to ecosystems. Entire ocean ecosystems could evaporate, meaning fish could vanish. Climate change polar bear statistics predict the species may go extinct as it becomes more difficult to find food. Mass migrations. Climate change affects agriculture and fishing, which directly impacts food safety. Some populations are forced to migrate in order to survive, creating climate refugees. All this causes tension surrounding the available natural resources, including water, and reinforces inequality amongst humans, especially in less economically developed countries. Acidity of our oceans. Oceans are carbon sinks, meaning they absorb CO2 from the atmosphere and store it. However, the accumulation of carbon dioxide in oceans changes their compositions and causes oceans to become more acidic. This phenomenon of acidification directly threatens the capacity for oceans to absorb carbon dioxide and produces death and disease to marine life. Species extinction. Coral. Yes, coral is an animal, not a plant. Two big issues that make coral an endangered species are pollution and warmer waters. Coral bleaching is caused by a rise in water temperatures, so coral cannot hold on to algae. Without algae, or without enough clean water for algae to grow, coral turns white and dies. I'm sure that you've heard of coral bleaching. There are only approximately 1,000 mountain gorillas left. There are less than 2,000 Bengal tigers left in the wild. Monarch butterflies are endangered due to extreme weather fluctuations and deforestation. The leatherback sea turtle and green sea turtles are at risk. The polar bear won't be able to find food. Asian elephants are becoming fewer. And finally, there are less than 8,000 African cheetahs and only about 50 Asian cheetahs left in the world. There are many more, sadly. Extreme weather. In the last 30 years, climate change disasters have tripled. 12 million people are homeless because of floods and landslides in Nepal, India and Bangladesh. While the monsoon season usually brings these natural disasters, they've never been recorded at this magnitude. Category 4 and 5 hurricanes have drastically increased since the 80s. And we all saw the wildfires in Australia in late 2019 and early 2020 that caused the Black Summer, which injected over 1 million tonnes of smoke particles as high as 35 kilometres into the atmosphere and caused chemical reactions that set back the recovery of the ozone layer by about 10 years. So now that I've given you some of the cold hard facts, what do we do about it? Well, to be honest, I could talk about it all day, and it's impossible to cover everything in a 30-minute presentation. So I'm going to focus on a few areas, including plastic pollution, VOCs, and how they contribute to climate change and this destruction. Then I'm going to talk around some of the environmental options available to our industry and offer some key considerations for you when making your decisions about what kind of products to use. Finally, if there are any manufacturers listening, I'd like you to take away points that you think you could consider implementing in your own ranges to make them more environmentally friendly and sustainable. So first of all, let's talk about plastic pollution. Plastic is made from fossil fuels, including crude oil and natural gas. These are limited resources in the world and we are using them up. All of the conventional plastic ever made with us is still on the planet, except if it's been burned. So if it's not currently in use somewhere, or it's been recycled, then it's in landfill sites, or worse still, it's in the environment. In 2021, a paper was published by a number of leading UK and American universities and environmental organisations titled "The Fundamental Links Between Climate Change and Marine Plastic Pollution." In this paper, the authors discussed how plastic pollution and climate change have commonly been treated as two separate issues and sometimes are even seen as competing. But here, they present an alternative view that these two issues are fundamentally linked Primarily, they explore how plastic contributes to greenhouse gas emissions from the beginning to the end of its life cycle. Secondly, they show that the more extreme weather and floods associated with climate change will exacerbate the spread of plastic in the natural environment. And finally, both issues occur throughout the marine environment, and they show that ecosystems and species can be particularly vulnerable to both. So plastic in a bottle form, for example, is mostly approached as a pollution issue though, and separate from the growing climate crisis. But plastic pollution is a global issue, just like climate change. It is found across all regions of the ocean, from shallow coastal areas to the deepest regions. It has been sampled in the most remote and sensitive locations on Earth. Marine plastic pollution is now found everywhere and is globally irreversible. Fortunately though, life cycle assessments are increasingly used to evaluate environmental and economic impacts of various plastic waste management systems. When we talk about the life cycle of plastic, I mean from the point the raw materials are extracted and refined, which you can see here in blue, then manufactured into products such as cleaning chemical bottles, which you can see here in red, transported and used, which is in grey, and then discarded at the end of their life cycle to be incinerated, recycled, sent to landfill or mismanaged, and unfortunately ending up in the environment. This is shown in the yellow section. Most of the sections can fortunately be evaluated for how much CO2 equivalent they produce. It's not good though. One assessment found that the yellow end of life section alone of plastic accounts for 9% of total greenhouse gas emissions of the entire life cycle of plastic. So now, the end of life section varies in the amount of greenhouse gas emissions produced, but for example, plastic waste incineration is generally considered to have the largest climate impact. In 2015, US emissions from plastic incineration was 5.9 million megatons of CO2. And these are expected to increase to 91 million megatons by 2050. That's a big jump. While recycling is considered more sustainable, it's not without its own challenges. It takes a lot of energy to recycle. It's expensive and can result in low quality plastics. However, when using 100% renewable energy throughout the process, recycling of plastics could allow for a 77% reduction in greenhouse gas emissions from that of virgin plastic production. So how big is our plastic problem? Plastic production increased from 2 million metric megatons in 1950 to an estimated 380 million megatons in 2015 and growing. Just in the production, transport and processing of plastic, in 2015, plastic production emitted the equivalent of more than 1 billion metric tons of carbon dioxide into the atmosphere. That's excluding the emissions I discussed earlier from the end of life cycle of all of these products. So should we or can we stop using plastics? Well, it's a difficult question and one that I am not qualified to answer. Plus, not all plastics are equal. Some are safer than others and easier to recycle, but some really are to be avoided. So how can you tell the difference? Well, some, but not all, will be marked with a plastic recycling number like this. These numbers range from 1 to 7, and I'm going to give you a very brief overview of the good and the bad. In our industry, cleaning chemical bottles will typically be made from type 1, 2 and 4, perhaps with lids made from 5 or 7. Now the good news is type 1 and 2 are easily recyclable. But the bad news is type 4, 5 and 7 aren't. Because they are either not easily recycled, it's not economically viable, or they just can't be recycled at all. Whilst black waste sacks are most commonly made from type 4 and sometimes type 2, they can be recycled, but generally they're not, because waste management crews can't see what's in them and if the contents are a contaminant. And also the laser technology used in waste sorting systems cannot recognise black pigments. So they're therefore not generally sorted for recycling. Then you have a second issue. Some of these recyclable options are not necessarily the safest plastics to use either, as they contain toxic chemicals which, unless they are recycled properly or stored in controlled environments, can enter the environment and leach toxic chemicals whilst also breaking down into microplastics. Only type 2, 4 and 5 are classed as the safest for not leaching chemicals. Oh, and by the way, type 3 and 6 are not easily recycled either. Just as a side note, some of the other plastics on the list, such as number 7, which is categorised as miscellaneous or mixed plastics, are practically impossible to recycle. This category includes lids, medical storage containers, sports drink bottles, large water jugs, reading glasses, CDs, DVDs, baby bottles, exterior light fixtures, fiberglass, Tupperware and more. On to microplastics. Across the board, they are an increasing problem. I'm sure you've heard of them. Fish and animals consume them, causing death and disease. Researchers think that between 10 and 30% of fish in any sample will be contaminated with microplastics, which can be a danger for the fish, as harmful chemicals can be then absorbed by them. This can affect their health, energy levels, and ability to reproduce. The issue isn't just limited to the waterways either. Microplastics are now being transported through the atmosphere over tens of kilometres to near pristine and remote areas. With the amount of contamination in the environment, microplastics are inevitably entering our own food chain. Only last week, a report was released proving tiny particles of plastic have been detected in the human blood for the first time. They were detected in nearly 80% of samples tested by a group of researchers from the Netherlands. While speaking about how microplastics can affect infants, Dr. Sanjit Sasidharan calls microplastics a curse to humanity. So are there alternatives to plastic? Well, yes, there are. Bioplastics are becoming increasingly popular as we search for alternatives to fossil fuel, with a more sustainable approach and circular economy. Bioplastics are made by converting sugar present in plants into plastic. That sugar comes from plants like corn, sugarcane, sugar beets, wheat or potatoes. And this makes bioplastics renewable and better for the environment than conventional plastics. Bioplastics offer lower greenhouse gas emissions in their overall life cycle compared to conventional plastics. However, this is highly dependent on the raw materials, composition, end-of-life management, and crucially, the carbon storage potential lost from their associated land use change. That sounds a bit complicated, and by that I mean, if someone's cut down a forest to grow the sugarcane, then what's the point? Because the carbon storage potential of the forest has been lost. What we also have to understand is that just because it has the word bio in front of it, don't assume that these products are helpful to the environment or are even safe in the environment. Bio-based plastics are not necessarily biodegradable, some are, but some only biodegrade under specific industrial conditions. And even if it is biodegradable, it doesn't mean it can be thrown into the environment. In 2019, however, the contribution of bio-based plastics to global plastic production was about 1%. Yet this is expected to increase, and it has been calculated that hundreds of million megatons of CO2 could be saved by substituting a fraction of plastics with bio-based plastics. Cultivating sugar for bioplastics comes with its own challenges though. Land is needed to grow the raw materials needed for manufacture, and the land needed for plastic packaging alone globally is 61 million hectares, which is an area larger than France. That's just plastic packaging. Changing the use of this land would also be damaging to biodiversity, and a life cycle assessment that took land use change from biofuels into consideration through greenhouse gas emission equivalents found total emissions to be similar between plastic made from both sugarcane and crude oil. But this is a rare example, and we do need more studies to make stronger comparisons in sustainability and greenhouse gas contributions, as well as firmer guidelines on how to conduct landscape sensitivity assessments when choosing where to grow. So there are a lot of things to think about here when considering your own supply lines. Will you make a more conscious, informed decision about the types of plastics used for your cleaning chemical containers? What are the plastics made from? Are they safe? Are they 100% recycled or partly recycled? Are they recyclable or reusable? Are they biodegradable, compostable even? Where have they come from? How have they been transported? How will you or your customers dispose of them? So what have we seen our industry doing to reduce its plastic usage? Some are using more recycled plastic in their packaging, some 100%, and some are concentrating cleaning chemicals so that fewer bottles are needed, which in turn reduces transportation and therefore your carbon footprint. You can speak to Greyland here today about their Maximum Eco range that do just that. There are companies too that are doing away with plastic container bottles altogether and dehydrating their chemicals to make soluble sachets which dissolve into reusable trigger sprays. And these are delivered in compostable cardboard boxes. Again, the carbon footprint of the product massively reduces due to the smaller size and weight of the product because it doesn't contain any water until it's dissolved on site. There is a company called EnviroShop and others who do this as well. Tisano and iClean Mini are famous for not requiring any containers or chemical at all and no transportation because their systems installed on site turn your ordinary tap water supply from O2 to O3, which works as a very effective cleaning agent. But I won't go into the science of it today, but trust me, it works. And the cartridges used in their system are 100% fully recyclable. You can speak to Killis here today about both these options. These are just a few ideas, but there are lots more. You just need to find the ones that meet your own environmental goals. Now that I've talked about plastics, what about what's inside your cleaning bottles? I'm going to talk specifically and briefly about VOCs, volatile organic compounds. Whilst they are produced through natural processes like plant and animal respiration and organic decomposition, they are also produced through man-made chemicals and are emitted as gases from certain solids or liquids because they evaporate very easily. They are in a variety of chemicals such as paints, paint strippers and other solvents, aerosol sprays, stored fuels and automotive products, pesticides, dry clean clothing, building materials and furnishings, and office equipment such as copiers and printers. But one of the big culprits is also cleansers and disinfectants. Volatile organic compounds are themselves directly an air pollutant, but also have a secondary effect. When sunlight and heat react with VOCs, ozone is generated and smog is formed. Some VOCs have short and long-term adverse health effects, but the ozone in the smog also inhibits plant growth and can cause widespread damage to forests and crops. These are some of the chemicals I'm talking about, and they are regularly included in our cleaning solutions. I'm not going to try and pronounce them. VOCs are found in glass cleaners, toilet cleaners, oven cleaners, dishwasher and laundry detergents, furniture polish and more, especially those with a fragrance. Did you know that consumer products, including cleaning products, emit just as much VOC pollution into our air as exhaust emissions from vehicles? But when you think about how much of those products you use in your daily life, you think, well, it doesn't compare to how much fuel I put in my car. But for every kilogram of fuel that is burned, only about 1 gram ends up in the air. Yet for these household and personal products, some compounds evaporate almost completely. It's that bad. The scientific evidence has indicated that air pollution within homes and offices can be even more seriously polluted than the outdoor air, even in the largest and most industrialised cities. So while the cleaning product sector is just one piece of the chemical industry, it still plays a role in climate change. There is a problem, however. It is really difficult to recognise VOCs on chemical ingredient labels. Unfortunately, labelling regulations in the EU and US allow product manufacturers to provide very little ingredient information to consumers. Go and check your cupboards when you get home. In Europe, only ingredients over 0.2% or known to be harmful are required to be on the label. In the US, the situation is even worse, and the manufacturer can disclose the ingredients they want to disclose. This means that most VOCs cannot be found on ingredient labels. So the easiest way to avoid VOCs and other harmful ingredients is to understand which ingredients you want to avoid. Phthalates, chlorinated bleaches, fragrances and benzene. And look for products that are free of these ingredients if you can. If you're not sure, ask. But don't be fooled by natural, hypoallergenic, sensitive skin, or green products. They may contain as many VOCs as other products, so this cannot be used to reliably determine product composition. So finally, cleaning product companies often talk about their impacts on climate change and ways they are reducing them, from the energy use in the production and distribution of cleaning products, to the use of chemicals and plastics, and the energy it takes to make those chemicals and packaging. But companies estimate the third category, customer use, meaning energy used by their customers when they use cleaning products. For example, energy for hot water to clean with, wash clothes or dishes, is by far the largest percentage. They estimate it between 75 and 95% of overall emissions. While this may be true, it unreasonably shifts blame away from corporations and instead places the responsibility on customers when there are things the companies should be doing more of to reduce their climate impact. Things like making less products, not a popular idea in our capitalistic society. Finding more renewable sources to make chemicals and eliminating the use of plastics, or at least significantly reducing it. Even recycling programs promoted by corporations often put the responsibility on individuals to recycle their plastics, instead of putting energy and resources into packaging options that will reduce new plastic waste from entering our environment in the first place. But while we work on changing policies and practices in the cleaning industry, there are additional simple actions we can start doing today when it comes to cleaning products and climate change. Buy less. A multi-purpose cleaner can serve many different functions. Opt for fragrance-free options when available. Fragrance products usually contain more ingredients and are often some of the most toxic ingredients found in cleaners. While these tips are helpful, it's really incumbent on the cleaning products industry to implement real solutions and move away from petrol-based chemicals, plastic, and marketing dozens of products that perform the same function. So I hope I haven't terrified you today with my presentation, but instead given you food for thought about the choices you might make now to change the outcome in 9 years' time and keep our planet healthy and beautiful for generations to come. Thank you for listening. And if you'd like to hear this again, it will be available on Floorbrite's YouTube channel in the next few days. Are there any questions? Thank you for your time.